Welcome back to the Architecting Intelligence Explainer series. You know, AI providers are constantly selling you on these massive 2 million token context windows like it's some kind of superpower. But what they aren't telling you, that lazy architecture is quietly bankrupting your production apps. Today, we're unpacking the hidden math of context window economics.
Here is our roadmap for today. We're going to cover the infinite context trap, the anatomy of that trap, the hidden performance killers, 4 massive context anti-patterns, and finally, how to implement a lean context budget. All right, part 1, the infinite context trap. So is infinite context quietly bankrupting your app? Right now, there's this dangerously incomplete framing in the industry. This idea that infinite context automatically equals better, safer AI. But the reality? Your context window is a heavily metered cost surface. Every single new feature, retrieves document, and agent handoff acts as a silent multiplier. You won't see it on your architecture diagram, but man, it absolutely dominates your invoice. Let's move to part 2, the anatomy of the trap. We need to look at the hidden math here. There's a massive disconnect between how we think tokens are priced versus reality. Input tokens scale linearly. Sure, that part's easy. But frontier models, they price output tokens 2 to 4 times higher per token. So when you push a massive document dump into an LLM request for a summarization or agentic workflow, you get this huge compounding effect. Bloated inputs inevitably drive really long, incredibly expensive outputs. Which brings us to part 3, the hidden performance killers. We have to look beyond just the basic cost. Killer number 1 is the time to first token spike, or TTFT. Context length and inference latency do not scale linearly. If you double your average context length, your latency spikes exponentially. Why does that happen? Because pre-filling a massive context creates a severe execution bottleneck in the attention computation. This all happens before your user sees a single word. Killer number 2 is attention degradation, which you've probably heard called the lost in the middle phenomenon. When you feed a model a really long context, its ability to reason accurately actually drops for the information stuck right in the middle. The model isn't deliberately ignoring it, it's just attending to it far less reliably because of the intense computational constraints of long context inference. It literally creates a total blind spot. The practical implication here is huge. Say you have a RAG system and you decide to retrieve 8 documents instead of the top 3. You'd think that's better, right? Wrong. Passing all of them in often degrades output quality. Those 5 extra less relevant documents actually dilute the model's attention away from the data that actually matters. So your most crucial information might end up right in that severe reasoning blind spot we just talked about. And killer number 3 is the compounding input invoice. Think about this number, 40. In a simple multi-turn agent chat that carries the full history forward, turn 1 adds 2 messages, turn 5 adds 10. By the time a user hits turn 20, 40 previous messages are getting pushed back into the model. This is a stateless rebilling loop. You are repeatedly paying for the exact same history on every single turn, even when most of it isn't relevant anymore. Okay, part 4, 4 context anti-patterns. Let's see how these costs accumulate silently over time. Look, these performance killers don't happen by accident. They're the result of specific anti-patterns. For full history carry forward, you need to transition to a rolling summary. Use smart graph summaries for older turns. For unfiltered retrieval injection, you've got to stop blindly passing top K documents. Instead, you must implement strict relevant scoring and semantic caching to put a hard ceiling on those injected tokens. Let's zoom in on anti-pattern 3, which absolutely hammers multi-agent systems. Agent state serialization sprawl. The naive way is to just pass the full accumulated state to each downstream agent. By agent 5, it's reading the entire output of the previous 4, most of which is totally irrelevant to its specific subtask. The fix? Structured state handoff. You have to define strict inter-agent API contracts that hand off only the absolute minimum input needed to execute the task. And finally, anti-pattern 4, system prompt inflation. This one is tricky because it's usually driven by totally legitimate product decisions. You start with a lean 200 token prompt. But over 18 months, you keep adding instructions for edge cases, formatting rules, persona tweaks, and suddenly, boom, it's 2,000 tokens, and you're paying for those on every single request. The fix is rigorous periodic auditing to strip away dead weight and setting up dynamic system prompt composition so you only load instructions genuinely needed for that specific request. Now for part 5, The lean context budget. Moving away from these anti-patterns means moving to a lean context architecture. You have to treat context as a strict budget. Remember, a limit is just something you try not to exceed. A budget is something you actively allocate. For a typical, highly streamlined enterprise workflow, you might allocate exactly 20% to the system prompt, 25% to history, 40% to retrieval, and keep a strict 15% buffer. Your exact numbers will vary, but the principle is universal. Every component gets an explicit piece of the pie. This architecture wins on margins and UX because of 3 steps. First, explicitly allocate those component budgets. Second, and this is absolutely crucial, enforce those limits before you ever send the orchestration request to the model. And third, monitor your context composition as a leading indicator of health. Don't wait for your invoice to show a massive token spend. Monitor what actually makes up your context right now so you catch the bloat before it becomes a billing nightmare. Part 6, Engineering over Marketing Hype. This brings us to the core philosophy of our explainer today, as Parth Joshi makes incredibly clear in the source material. Context is a budget, not a limit. The operational and economic properties of your AI systems are determined strictly by architectural decisions you make at design time, not by runtime tuning. Teams that explicitly design for a context budget spend less, they run faster, and they reason better at every single scale. Infinite memory? That is just a marketing metric. Efficient context, on the other hand, is a rigorous engineering discipline. Every token you pass into a model is a decision, and it's time to stop making that decision by default. Seriously, it is time to stop paying the lazy loading tax. So ask yourself, have you run a context composition audit on your production system today? Do you actually know what percentage of your average context is just dead weight? Next week, we kick off a brand new chapter in enterprise systems. Hit subscribe to keep your architecture optimized, and definitely go read the full technical breakdown over on Parth's Substack. Catch you next time.